Okay, pre-cal, we have our next 1.6 video, so this is going to be composition of functions. So what does composition mean? Well, it's basically a way that we can combine two functions. Okay, so that's what composition is. So we learned in the last video we can use basic operations to combine them, but now we can combine them in composition. So what does that look like? Well, here's what it means. It means basically that if we have two functions, one function can become the domain of another function. So let's say I give you f of x and g of x. So we've got two functions. So what it means to be composed is that if f of x is composed with g of x, we have f of g of x, which means g of x becomes the domain of f of x. All right, so basically, as you can see, the domain is x, and the g of x becomes that. So, and it doesn't just work with f. If I wanted to compose g of x onto f of x, then I would have g of f of x, and f of x could become the domain of g. So that is essentially what's happening. So what does this look like practically in an equation or in a problem? Well, essentially, you're going to be given some functions here. So in this particular set of examples, I give you 4, and there's a couple of different ways. I didn't go over this. This right here means g of f of x. That's how we say it. So g of f of x. That's how we're going to say that. Another way to write this is just like this. And I know what you're thinking. That looks like Goff. But we don't call it that because that little symbol, it's just that. It's a symbol. It's just a little circle symbol. It's not the letter O. So that's another way to write that. So if you'll notice down here in your examples, I have it written both ways. See, f of g of x right here, h of g of x, s of g of 2, h of f of x, g of f of 1, g of h of 0. Now, number 3, number 5, and number 6 are a little different. So we may do those in a separate video. It depends on how long this video gets. Okay, so let's look at number 1. I've got f of g of x. Well, here's how I'm going to write that. All right, I've got f of x first, okay? F of x is equal to x squared. Okay, I got that right here. G of x is x plus 1. So if I have g of x as x plus 1, that means I'm going to replace this x with the function of g of x, the whole thing. So f of x plus 1 equals x squared. That's what I'm going to do. Now, all of this gets substituted in to x. So f of x plus 1 is x plus 1, and you guessed it, squared. Now you have to be careful with this one because you have to remember your algebra 2. Remember that x plus 1 squared is actually x plus 1 times x plus 1, and you have to FOIL it. So that means I'm going to have x squared plus x, and then 1 times x, and then 1 times 1. And then I'm going to combine like terms. So f of x plus 1 equals, I'm going to write that down, x squared plus 2x plus 1. So there's my composed function. All right, let's look at it on number 2. Here I've got h of g of x. So h of x is right here, negative 4x minus 2. And g of x, as we already know, is x plus 1. So h of g of x. So g of x is going to become the domain of h. So that is h of x plus 1. So where the x is, now I'm going to substitute in x plus 1. Oops. Okay, so negative 4 times x is negative 4x. Negative 4 times 1 is negative 4. And then I've got this negative 2 out here. I'm going to combine like terms. So negative 4x minus 6. So h of x plus 1, h of g of x, is negative 4 minus 6. See, it's not horrible. Things could always be worse, kids. Okay, 3 is a little different. S of g of 2. So what does that look like? Well, I know I'm going to compose s of x with g of x. So s of x is negative 2x squared plus 3x minus 1. And g of x is x plus 1. But I don't want g of x, do I? I want g of 2. So I'm going to find g of 2. And that's just going to be 3. So what I actually want is s of what? S of g of 2 is s of 3. So s of 3. So I'm going to substitute in a 3 everywhere I see an x. So I get negative 2 times 9 plus 9 minus 1. Negative 2 times 9 is negative 18 plus 9 minus 1. So s of g of 2 is equal to negative 18 plus 9 is negative 9. Negative 9 minus 1 is negative 10. Okay, so the only difference is if you're taking s of g of a number, then you're going to get an actual value for your answer instead of just an equation. So that's how that's different. All right, so this video is not too terribly long, so we'll keep going. So h of x is negative 4x minus 2. F of x is x squared. So I want h of f of x, so I'm going to replace this x with f of x. So I've got h of x squared. So in my equation now, I'm going to replace the x with x squared. And I'm going to distribute my negative 4. So that's h of f of x. Beautiful. Okay, we will go ahead and start another video to finish these just because I've got 3 more examples and I'm going to go ahead and fit in your composition of functions graphically in your next video. So we'll do another one.